Hello and welcome to a mini tutorial series on Rivet. We will see how far we go and how many parts we do, but Rivet is a really cool tool, but the good thing is that it's really complex. So you can basically do all the things you want and you can do it in lots of ways. The bad part of that is sometimes it's confusing to know what is the best way. And some of the obvious looking ways, like if you want a loop, like if it's a for loop or a while loop, you will always use the loop controller, are actually probably not the best ways. And yeah, that's what this video is about. We are going to look at a typical case for a for loop, where we have we know how many iterations we want to do and we want to iterate over something, which is a typical situation to use it. And yeah, let's just jump straight in. Basically, we will look at three things. We will first look at, we have three examples. We go grocery shopping. I will explain what this means in a second. And first of all, we will look at the loop example, the traditional one. Then we will look at the same thing without a loop. And then we will extend this a bit to show you that it's still possible to do a bit more complex things, even though we are still not using the loop. Yeah, okay, so let's get started. First of all, what does that mean we are going grocery shopping? It's pretty simple. We have a list of items we want to buy: apples, bread, milk, eggs, and cheese. And so basically we are building an array. And I mean, at the moment, we are not doing much more in this loop than ticking off the items. It's very simple and very basic, but it's a good start to take a look at. So let's take a look at this here. This is our loop controller. And yeah, as you can already tell, it's not exactly self-explanatory because, yeah, I mean, you can see our list of arrays is going in here as a default of data 1. That is still pretty clear. But if you look here, then there's pop going in, and there's pop question mark going out, and there's array question mark going out. So I will not try to explain to you, but you will see this is some of the reasons why I think it's better not to use it. Because in the end, especially if this gets bigger, it's harder and harder to understand, and maybe you still know what you're doing when you build it. But once you need to change something or extend it, you are going to have a bad time. Okay, but let's keep it. So we are moving our list or our array in here. This is what we want to iterate. So let's first look into the loop itself, what it does. So here is our input from data 1 is coming out, and in the first iteration, it will be just our shopping list as we built here. And now we pop the first item from the front, so the first item of the array will be our apples. And this is going down here, and we are building a custom text which just said that apples have been added to the cart in the end, in this case, or whatever item it is in the iteration. And then we actually create a new array which consists out of some of data 2 input, which is at the beginning an empty array, as you can see here. This is the default for data 2. So basically this will first now just add this to the array. And then we are moving this back into the loop controller for the second iteration. So now we have this also in here as a data input. So this is our new list with the items we added to the cart, our new array. Okay, and what we of course also need to do is we need to check when we need to stop the loop. So what we are doing here is after we pop the first item from the array from the front, so we took that out, we will look at the rest of the items. So basically we have everything left but apples. Now we have bread, milk, eggs, and cheese here in the first run. And then we put this to a new array again. And we are taking the length of the array so that we know how many items we have left. And we're comparing if our items are still bigger than 0, because then this is connecting to the continue port, and then we will continue the loop controller. Once our items are, this condition is not true anymore, then a false will be sent in, and that means that we are going to break the loop controller, and we are finally getting here. So let's start this up. And as you can see, as a result, we just have our new array, which just states that apples were added to the cart, bread was added to the cart, milk to the cart, eggs to the cart, cheese to the cart. And let's be honest, this is a lot of work for just that. Don't you think so too? So let's look at something simpler. Let's look at the first non-loop example. The only small complexity that's coming in now that we also need to learn how to use subgraphs. But it's also just, if you know it, it's pretty simple. It might just be not obvious when you see them the first time. So, but basically what we have now here is, we have the same inputs. We are building our array for the shopping list. And if you want to simplify this, we could also just add an object. So if you know JSON notation, you could just add this JSON object in here and just connect that. So you could actually make already all this here obsolete, because it's, let's be honest, this is not also a lot of stuff for such a simple thing. And what we can see here now, this is going to a subgraph, and then there is an output. So first, let's show you what a subgraph is. Let's get in. A subgraph is basically just like just a normal graph, but usually, I mean, it doesn't need to have it, but usually you can have one or more graph inputs and one or more graph outputs. Yeah, small note, those colors here are not usual. I just like to add them because if it's getting a big graph, you can clearly see what the inputs and the outputs are, where they are in the graph. So I like to color code it all a bit. Same actually for the subgraph here. I like to make subgraphs yellow, so I always see if something is going into a subgraph. But basically for this one here, we created a graph input called item and a graph output called output. And what this now means is, if we go to subgraph here, then first of all you see nothing, so it's a bit odd, so you need to go to the configuration, but now you can select a graph. And now we can select this subgraph here, and then it will automatically have this input as you decided on the output. So it's actually a pretty custom thing. You can create as many inputs as you like, as many outputs as you like, and I mean, you don't need to have an output. You can also have a subgraph without an input, but then it will just run automatically once you start the graph it's in. Yeah. Okay. So now there's one thing which is the secret sauce in here. Because let's say we would just throw this array in here. Let's actually do this. Let's first move it out. Let's just throw the array in here. Let's the subgraph make its magic. And then we have, we have something pretty odd. We have added apples, bread, milk, egg, cheese to the cart. So we just threw the whole array in at once. And we added text around the array. That's not what we wanted. We want to check off each item separately. So how can we do that? There is this really not very well explained feature here, which is called split. Once we put this on, any array input that we use, like this one here, so our grocery list, will be split. And this subgraph is now going to be called for each item. So let's run it one more time. And now we can suddenly see, oh, yeah, now we added apples to the cart, we added bread to the cart, we added milk to the cart, and so on. So this is the only small thing we need. Just this one check mark here, and any array you ever have will automatically be being sent, as every single item will automatically be sent to a subgraph and being run once. So basically, that is the absolute simplest way we can ever create a for loop and iterate over those items. So now you can also, if you think it's necessary, you can also make this sequential. This is even running in parallel at the moment, which is of course quicker. And you can also have, like for the loop controller itself, you can also say what the max iterations, or in this case more like what are the max items. So if we put this only to, like, let's say 3, then we can see here that we only took the first 3 items. So let's move it back because we need a higher number. And let's go one more time to the subgraph. And now, instead of having all those complicated things of creating a new array, removing things from the first array, I mean, what we can do now for this use case is we don't have to do anything. We can just create the text and put it to the output because, yeah, now we are adding this to the card. And what's pretty cool, if you want to debug this, is maybe on one of the runs something happened. You can see the executions. You can change them here. You can change even for all the nodes. So this is the first execution. There was apples, added apples to the card, and the output is also added apples to the card. But you can go to the second, and you can also switch it for each node separately. So it's really easy to look at, and it's really easy to understand. And that is the second reason why subgraphs are good in general. So even if you would be using the loop controller, might still be recommended to use a subgraph inside it to simplify the process and to help you being able to debug it. But generally, maybe that is worth another video on itself. Okay, now you say, yeah, I mean, you just removed all the complicated part of the loop. That's why this is simpler. And I mean, you're kind of right. So let's take a look at a more complex example. So in this case, we are going shopping, but it's a bit more realistic because of course we have a shopping list. That's okay. We still want the same items, and I'm now using the simplified way of building an array here because I think it's easier and it's nicer. But well, reality hits hard. We only have $10. So most likely we cannot buy everything on our list. And for that to be decided, of course, we need to know the prices. So down here we have a price list now. And you can see cheese, for example, is $3 or whatever currency we like to see it in. Bread is 2 and so on. So yeah, now we have a bit more to do. We have to find the items on our list, and we also have to keep track of the budget. And once the budget runs out, then yeah, we cannot, of course, not buy everything anymore. So basically, this is now a bit like a priority list. Wherever our budget is exceeded, then we need to stop buying new things. Let's run this quickly to show you the example, the result first, and we can see, okay, now we first added apples to the cart, and we have a total cost of $1.5. Then we added bread, still below 10, added milk, still below 10, added eggs. But then the cheese, the cheese was $3, so that would have put it to $10.2, and yeah, we did not add that to the cart because our budget was exceeded. So let's see how we did that. And first of all, it's very important now, of course, that we do this sequentially, because if we do it in parallel, then yeah, everything gets thrown into the cart at the same time, and there's no way we can tell what exceeded the budget. So in this case, this check mark here is really important. And as you can already tell here, we now also have more inputs. We don't have just the item, we also have the budget, and we have the price list. And please note, those are not arrays. So this is an array, and this will be separated when we put it in. So apples first, then bread, then milk. This number here will always be the same, and this object here too. Let's look at this in the subgraph. So let's look at the inputs first, and let's go to the first one. So as I said before, we can see apples is coming in as an item. The price list is the full price list, and our budget is 10. And that is the same for every run. This changes, those two stay the same because they are not arrays. They do not get split. So you basically have full control. If you want to put multiple arrays in there that are supposed to be split, then this also works. Okay, and now of course we need to do a bit more actions here. And you can see it's already getting a bit more chaotic, and honestly speaking, this could already maybe call for another subgraph inside this graph to make it even more, easier to understand and read and handle in the future, but let's just take a look. So the first thing we are doing, we need to get the price for the list item. And for this, we actually need to match our key, which is in this case, for example, milk, in this list to get the value for it, so 2.5. And that is the node that allows us to do this is the extract object path node. Now, we also check this. Yeah, not okay. Actually, there is now at least a text if you hover it, but this not very clear check mark here, because this allows us to also have the path here as an input. Let's put it off just to show you. Now the path would need to go here, and then it would be hard-coded, so we cannot change it with every item, but we need this here. So let's reconnect. And basically what we are doing here is we are creating our path. This is JSON. Yeah, this is also some way to get things from a JSON object. If you don't know the syntax, basically you can just ask ChatGPT to write it for you. It's not too complicated. But basically, yeah, from our object on the first level, we are looking at the key milk, and then we want the results from that. And as you can see here, this extract object path is now returning us the 2.5. So this is the correct price for milk in here. Then, of course, now we need to somehow keep track of the total sum we're at. And for that, we are getting the value from a global variable. Of course, in the first run, this variable has a value of 0 because we never set it. But we put it to type number, so the default value that's being returned is 0, as you can see here. And then we are adding this to our price we just found for our first product. So basically at the moment we're at $1.5. So if we look at this in a next iteration, or let's take the milk example from before, then we found the price of $2.5 for the milk. We already have used $3.5 of our budget. So in the sum at the moment, if we would buy the milk, we would get to $6. And basically this here is now allowing us to check if we can actually buy this item or if we already exceeded the budget. So there is a simple thing here, which is just a comparison. We are comparing if A, which is our current budget if we bought the last item, is still exceeding or is still lower. Sorry, it's still the same or lower than our budget. So if 6 is smaller or equal to 10, basically. And as we can see here for the milk, this is true. We are still going on. And then we are using this, putting this into an if-else node. This if-else node helps us to split, now send different results forward depending on this. Basically, it looks a bit maybe a bit daunting as well, but it's pretty easy. So we're putting this true or false value into this if-else here, and then if it's true, so like here, currently it's true, then we will take the value from here. So we will take this $6 and move on with that. And if it's false, then we will use the previous budget because we were not able to add the item. So let's look at this, how this looks for the case of cheese, which did not fit into our budget. So now we calculated that we would get to 10.2 euros. So in this case, this output is false. And that means that the if-else node is using the value from the false input port, which is the total cost up here, the current total cost. So how much we already used from our budget. Okay, and now finally, there's also the part where we're actually setting this global variable, which we previously already got a value from here. So we are now updating our budget value. And in this case, as we were not able to buy the cheese, we are basically putting in the same value as it was before, 7.2. But let's go back. In the previous case here, our old value was 6, and we now bought, what did we buy? We bought X for $1.2. So we went up to $7.2 and we added this and we saved this here. Okay, and now basically we are creating two texts, and we are just always creating them. So basically, as you can see here, we create a text that we added X to the cart and what our total costs are, and we created a text that we did not add them to the cart. But we are not always using both of them. That is the trick how it's working, because now we are just doing another if-else port. We are again checking, if you look at the yellow line, the same compare as before. We are checking if this item still fits into our budget. And if it's true, we will use this text here that we edited. And as you can see, we have variables in here for item and total cost, so those values are dynamic and will be correct. And in the case of false, like for cheese, we will take this input here. And now we will add this text. And then we go to the output. Okay, this is the first video I'm doing, so I hope this was helpful. It's hard to tell. Maybe it was too much. Maybe you guys are like, oh, this is so obvious and so simple. Why are you doing this? Maybe my camera quality sucks. Maybe you could barely hear me. Leave me any feedback. I would be very, yeah, I would really like you to, I would be, yeah, liking it if you give me some feedback on how I can improve this. Of course, if you like to want to give me a like or subscribe, that would be super nice. And if you want to see more or have either ideas or even better solutions for this, then also please just write me in the comments or in the Rivet Discord. Thank you very much, guys. See you.